So Venn diagrams, I think you're going to want to read through this sort of on your own. I've asked you to start by reading through, but I just want to kind of take a synopsis of what we're talking about here. We're given a situation where we got John, Cindy, and Mike have MP3 players. Majid, Lisa, Monica, and Mike have cell phones. I'm noticing that Mike is repeated here. William, Manish, Deepa, and Marilis believe that their lives depend too much on technology, and so they have neither an MP3 player or a cell phone. So first thing we need to decide is that words that we're going to use is we've got this idea of the universal set. So when I hear universal, I think of the universe. The universe is all encompassing. So our universal set is all the data that we're talking about. All right, and so that's what we're going to be representing by our box. And notice that in the Venn diagram, we visualize the universal set as a rectangle. So this is part of our Venn diagram. So that whole rectangle is where we start with our Venn diagram. So in this particular case, we've got to ensure that all of our students end up inside of our diagram. All right. We can then start talking about sets within that, different groupings within our whole group of kids. So we've got a set of students with MP3 players or with cell phones, and some of them have none. What we can now talk about are subsets. And so when we start with a subset, we're going to give it a label. We'll talk about our students with an MP3 player. So those that had an MP3 player, let's call it set M for MP3. I use a capital letter to denote that subset. And there are 3 people in it: Cindy, John, and Mike. So I'm going to circle that and create that as a one group within my Venn diagram. And so my circle M is a subset, a small portion of my entire group of data. And that set M is equal to curly bracket, and then who's inside of it? Cindy, John, and Mike with a closed curly bracket. We call Cindy, John, and Mike elements. So the term element just refers to the data points that are inside of it. A lot of times when we were looking at questions, we'll kind of be referring to numbers, right? But any data that is inside of our subset, we call those elements inside of the data. Another term called the complement of M is the exact opposite. It's like saying not M. So it's going to be including all data inside of my universal set that are not inside of M. So given that our players of MP3 were Cindy, John, and Mike, those that do not have an MP3 players are the remaining students: Majid, Lisa, Monica, William, Marish, Deepa, and Marlies. Okay, so it's just the opposite. When we talk about the complement, it's the opposite. We also mark that with a prime, so M prime or an M apostrophe, and it's this apostrophe mark up at the top that refers to the complement of the set. Questions about that? So if we look back at our previous page, oops, total number we've got 1, 2, 3, 4, 5, 6. Mike was already been counted. 7, 8, 9, 10. We have a total of 10 elements. So we have a total of 10 elements that are inside of it. 3 of them have MP3 players. That must mean that the complement of M adds up to 7. 1, 2, 3, 4, 5, 6, 7. Okay. So this is what would this be equivalent to? What did we look up? One of our problem-solving strategies before? What do we call that problem-solving strategy? Anyone remember? I don't remember what we called it. Something like like when it's not included. Sometimes it's rather than counting up all the elements of a certain set, it's easier to count the elements that are not in that set and then subtract it from the total set. That's the idea. What was their name for it? The indirect method, right? So the idea of the complement is the same concept as the indirect method. Okay, thanks. Now we're going to be talking about the intersection of two sets, so things that are common. So in this particular case, the intersection is denoted by the word and. So who has an MP3 player and a cell phone? We call that the intersection of these two sets, and that's denoted by the information that's contained in the middle. So in this particular case, who had both a cell phone and a MP3 player was Mike, right? So that here would be Mike that is on the intersection of those two, okay? And I think we, from our pretest, that idea of intersection seems to be clear. I think we understand that. Now, the way that we're going to write that is going to be M with the intersection of C. So it's kind of like an upside down U is the symbol. And the way, one possible way of thinking about that is it almost looks a little bit like an A, right? It's not an A, but it looks a little bit like an A with that cross symbol. So that upside down U is the intersection. Okay, in this particular case, A and B have no overlap. There are no common data points between A and B. So this is a diagram. It's not referring to our cell phones or MP3 players in this case. But when there's absolutely no overlap, this is going to be known as mutually exclusive. Okay? When there's no overlap whatsoever, they're mutually exclusive. Or we could also say that A intersected with B has nothing inside of it, right? It's the empty set. So we denote the set with those curly brackets. If there's nothing inside of it, we call that the empty set. We might also see the word disjoint sets. So mutually exclusive, disjoint sets, empty sets would be for the intersection of A and B has an empty set. Can I go on? Now we've got our OR. We'll call that, instead of the intersection, we're going to call it the union of two sets. So in this particular case, if I'm talking about the number of students that have an MP3 player or have a cell phone, we call that the union. And the nice thing is now we're using like a U. We can think of that as being the union. This refers to OR. So the union of M and C would be, I'm not going to write all the names, all people with MP3 or cell phone. And that would be shown in the diagram as everything inside of M, everything that's intersected with M and C, and everything that's inside of C exclusively. Yeah, so that's the union. Let me write that with M union C. Note that it's not actually, when we look in our, I don't know if you can see on the on your paper, it's not really a U, it's sort of a wider U. And so if you're going to be doing something on the computer, you'll actually have a special symbol. If you're ever doing a math equation, you'd see that there's a sort of wider U or that wider upside down U to denote intersection or the union. Okay, so in summary, we got our elements, are just the data inside of our set. The universal set includes the universe that we're looking at, all the data that we're concerned about. It's important to define what our boundaries are. What is it that the data that we want to be considering in our problem? The empty set means there's no elements inside of it. It has no data. The complement of A is the everything that's, we might also say it's not A. Anyone that's done computer Boolean logic, the complement of A would be the same as not A.